So what do we need to do as BAs here? We need to first make sure that the requirements are of good quality. And for that, what we were discussing the other day in terms of making the requirements complete, ensuring that consistent, atomic, concise, feasible, prioritized, testable, understandable, accurate, all of those verifiable, estimatable. In the context of agile, it would be about the invest principle, making sure it's all independent, they are negotiable, they're verifiable, estimatable, sizable, and testable, right? So that's the important sets of attributes of a requirement. If you do not have any requirement which meets these this set of criteria, then perhaps you need to actually go back and see how can you try and make it more atomic, how can you try and make it concise, how can you make it more feasible, what are the different aspects that you need to consider to prioritize those. So for example, using Moscow principle, right? All of those need to be done here. And once you ensure that the requirements meet these standards and or of this kind of parameters, then you would make sure that you carry on with compliance. If you need to check the compliance with respect to the organizational standards, with respect to regulatory standards, for example, if it's banking and risk related stuff, insurance, you need to check with the industry standard and domain specific regulatory compliance. Is it meeting those standards? If it is automobile, is it meeting the standards of Euro emissions and all that, for example? So all of those need to be really considered. Healthcare, HL7, HIPAA, those are the standards that need to be met. So all of those, you're trying to make sure that not just with respect to your organization specific concepts, but also the industry guidelines and industry standards. And then you need to make sure that you've got the correct set of notions, the templates. You've used the latest template and not something that was dated, because perhaps things would have moved on. We would have added more features or made it more concise and simple. So we need to kind of use those as the baseline for us. And then we also need to make sure that you are comparing these requirements, the models, the prototypes against important things which are accepted within your own organization, with your own team. So you don't really make out of the way assumptions or constraints. You have got something to base your models, your requirements against. And for that, there could be a kind of a checklist that you can use. You can use some of the checklists, some of the standards that you have, like W3C, the World Wide Web community, which is basically the W3C standards for defining the website accessibility guidelines, for example. Or you can try and use IEEE, the Institute of Electrical and Electronic Engineers. They came up with a set of standards and protocols that need to be followed. Similarly, AIEEE, each of these different bodies have come up with their own way of defining the standards of quality. Some of them, for example, even ISO, the British standards and the ISO standards could also be followed as a kind of a checklist, whether you've covered all the bases. And that's important for you to say, yes, these are now for good quality. And when I say good quality, this is what we were talking about in the previous course as well. This is what constitutes a good requirement. So it needs to be current, it needs to be concise, conformant to the standards and the compliance regulatory rules and requirements. The requirement needs to be correct in terms of what it is trying to capture, what it's trying to say. It needs to give the correct information and not something that is invalid. It needs to be consistent with the overall set of the product guidelines and the specifications. It cannot throw something in the odd and saying that this is not matching with the overall experience that you're trying to deliver. So consistency is again very important. It needs to complete. It needs to be a self-contained unit within itself, so you can actually pick that one and be able to work on that. And again, using the concept of invest principle that we were talking about, it needs to be independent. It needs to be negotiable. Those I and N from the invest principle of the user stories again applies here. And then the cohesive. It needs to be cohesive, as it cannot be just odd person out and not sitting in the context of where you are. So it needs to be fitting in well. It needs to actually gel well with the existing set of all the other requirements. It needs to be categorized. There are different ways to categorize the requirement: functional requirements, non-functional requirements, general requirements, solution requirements. We're going to have a look at it slightly later. I'll walk you through what could be the potential categories, in terms of how we can look at requirement, what are the types of requirements, and it should be clear and understandable. You cannot, use, verbose requirements, too much of text, too much of content out there, which is not making any sense. It needs to be really simple, lucid, clear, and to the point. And then feasible. The requirement needs to be feasible in terms of making sure that you cannot really ask for something really which is ambiguous or ambitious. It needs to sit in the current context of the platform, the technology. There's always a give and take there. I mean, it need not be always that you're not talking about feasibility from the technical point of view, because we have not yet known what technology we're going to use or the platform we're going to use. But from the functional point of view, this needs to be feasible. That's what is the whole idea. So you can ask, how can we determine right now what is feasible or not? It's not about that. It's not about technical feasibility or platforms or tools and techniques. It's more in terms of functionality. That is, it is sitting in the context of what we're trying to do as a business or as an organization. It's a value point of view. And relevant, it needs to be relevant to the current context, pretty much like current. It needs to be relevant to the business, to the domain, you cannot create a requirement which is not sitting in the current context of, for example, if it's a insurance application, kind of a project that you're working on, you cannot insert a requirement to do with healthcare or retail. So it needs to be relevant. It needs to be fitting into that context, and it needs to be identified with the owner of the requirement. Sometimes it's not the BA always who owns the requirement. It's also could be the sponsors or the people, the business sponsors, the business owners, the business unit head, or the project sponsor, the program manager, project director. All of these could be the owners of the requirement sometimes, in terms of identifying who has given that requirement, who could take it through the implementation. Traceability, as we discussed in the previous knowledge areas as well, traceability is very important, so that you can kind of understand and trace and monitor how that requirement has been fulfilled across the journey from the stage of requirement, or even before it actually has been logged in as a requirement, how it came through. It could be from the customer reported defect, or it could be from the competitors' way of how they handled it in a separate feature. It could be anything, or it could be a regulatory requirement coming in from the top body of one of these, like FDA, Food and Drug Administration, the Financial Conduct Authority, or any of those kind of regulatory bodies. It could be those, or so they that's the source, and from there on you've logged in as a requirement into your product, and there from the requirement through to the the architecture, from the architecture design, high level design, low level design, the development, the test cases. So the complete set of the entire cycle of activities around that particular requirement, you should be able to trace forward and backward as well. That's the whole idea about traceability. Implementation independent, yeah, that's what we were talking about when we talk about feasible. It's nothing to do with the technology underlying or the platform underlying the whole solution. It should be irrespective. It should be agnostic of the platform. It should not be about implementation. It's about the analysis. It's about the specific, the customers, the users, and the stakeholder specific. It's nothing to do with the how you're going to solve that problem. It's about that problem itself. It should be unique, so that you can try and give an ID or identifier to that, and you can track and trace it all the way through. So you cannot just have some kind of a commodifying things. Otherwise, it would not be able to track and trace and monitor all the way through. So it better need to be unique, or some kind of a unique identifier needs to be attached to it. Unambiguous. It should be really specific and clear in terms of what it's trying to convey to the stakeholders, the people who are reading it. Modifiable. You should be able to edit that. So for example, if you say something today, and perhaps 2 months down the line, if you want to actually change it based on, for example, some business rules that have got some link to this requirement, if they changed, you need to be able to come to this requirement and then change it because something else changed. So that kind of maintainability is what we call. That should be there. And then testability is in terms of that being able to verify, validate, and test that requirement to the and to the core, and make sure that it is actually implemented in the proper way. So this is kind of a set of qualities that you should have for making sure you write the requirements in the proper way. This is again another way that I put together to, to convey in what cases how we can kind of progress through the requirements in the life cycle, and we call this as the V model. This is called the V model. So basically, you start off with the scoping of requirements, and then you need to have a test strategy in place at that point of time. So essentially, on the left side is what you do here as a life cycle. It's not really waterfall, even though it appears to be like a waterfall. Starting with scoping, architecture, design, low-level design, development, and then testing. It could have like they could go into iterative kind of loops. But on the right side, corresponding to each of these, you are trying to do the testing so that it is at each and every stage you are verifying, validating whether you're doing the right thing, whether you've got the right thing, you've got the correct set of requirements, you've got the correct set of designs. So it's basically that verification, that validation, that kind of assurance you're getting from the team. So you start off at this stage, the scope and requirement with a very high level test strategy. As you slowly get down to the requirement, the architecture, you've started writing the acceptance test cases and things. And then when you've got the system design in place, you're looking at system test cases. When you've got the low level design, you start looking at that's when you identify the components, the interfaces, the modules. So you can start thinking about the integration test cases. And then when you start development and have some kind of code ready so that the functionality is now ready, perhaps 1 or 2 pages of your product, web page or a website is ready, then you can try and do the testing. Actually, from here on, you can actually do the testing. Till here, you're actually trying to write the test cases, have the test plans ready, have the test strategy in place. So once the build is ready in terms of development, that's when you can start the unit testing, the system testing, acceptance testing, and then you can do the integration testing. So at each of these different stages, you are trying to validate and verify your requirements and saying, yes, are we trying to achieve what we have set out for? Is it conforming to the requirements? Are we meeting the requirements? So that's the kind of set of activities that we do when we engage in the software development process. So this is what is called a V model, very, very important V. So basically it's like this, the way it is structured is a V shape. So this is called a V model, verification, validation, and testing essentially. And when we go forward with this, so again, this is basically one of the things that I propose is you need to engage not just with the testers and the QA people in the team, but you also need to engage the users, the end users, and the customers in this process. So test product thoroughly, yeah, very important. But more important is user testing. Engage the users, have them a view of this product. Let them have it go with respect to how the product works, what are the features of the product. Let them use the product and then give us the feedback. And once they give us the feedback, then we can try and enhance the product. Then it goes into the finalized release and then deliver the product again. So it's like a continuous loop again. So it's important that we're not only testing the product from within, like all the tests that we did just now, which are all done in terms of internal test teams. So all of these acceptance testing, system testing, integration testing, module testing, performance testing, unit testing, they're all performed internally by the test teams, which are internal to the organization. But when we talk about user testing, it's something that you're engaging the customers and the end users, and you're actually trying to get the, as they say, the rubber. That's when the rubber meets the road. That's when you really get the real feedback and the real experience of how the real end users would feel about using your product. So that's what it's called as a litmus test for this asset. It's the asset test. That's the touch point. Till now, you're really talking internally. All these defects that you're logging are all primarily just from internal point of view. But the first and foremost thing, when your product or your process or service falls into the hands of the end users and the customers, that's when it would start to really give the complete feedback, give the real best feedback about it, is because they use it day and day. They are the people who can actually relay the best feedback, and how you can improve their product, because it's essentially their product. You're helping build their product. So this is again a very important aspect of software development, to be able to get this feedback early. And that's why they say with agile mode as well that it's fail fast, right? So the earlier you get your products to the customers and users, the better, the quicker they would give you the feedback, which means potentially that you failed in terms of delivering to the expectations or the requirements, which means you're failing early than later, after about 10 months or 1 year, when you go back to the users. By that time, significant damage would have already been done. But instead, try and fail early, fail quicker, so you can recover quick, you can rework on those defects, you can change your course quicker than when you go down the path of that and you self-destroy yourself. So it's important that we fail faster and we get the feedback early. We take in the feedback, continuously improve the product, again deliver, get the feedback, and that's how we make these loops smaller and quicker. And that's again a beauty with agile. That's a really nice benefit from agile